Section 15.2, line integrals. So the first one, evaluate the integral along the given path. Integral with the path c, x, y, ds. And r of t, 3ti plus 4tj, and t between 0 and 1. So r of t, 3t and 4t, r prime of t is going to be 3 and 4. Now here's the rule we're going to use. Fx of t, y of t is going to be square root of x prime of t squared, y prime of t squared. So that means this is x prime and here's y prime. So x of t, this is x and here's y. So it's going to be 3 of t, 4 of t, square root of the prime, which is 3 squared, 4 squared dt. Now this one is going to be 12t squared, square root of 9 plus 16 dt. From 0 to 1 is going to be 12 t squared, square root of 25 dt. 25 is going to be 5. So 12 times 5, integral 0 to 1 t squared dt. Is going to be 60 t cubed over 3 from 0 to 1. It's going to be 1/3 minus 0. That means 60 times 1/3 is going to be 20. So this is the first solution. It's going to be a 20. Just gonna check that. For number 2, we're gonna do the same steps, but we have our integral for x squared plus y squared plus z squared ds, and our r of t sine ti cosine tj plus 8k, and the t between 0 and pi over 9. So here is the second one. Let's check how we're going to solve it. We're going to do exactly the same steps. So r of t, sine of t, cosine of t, and 8 in component form. R prime, cosine of t, negative sine of t, and 0, t between 0 and pi over 9. So our f of t is going to be, this is also f of t with x of t, y of t. This is x and this is y. And this is now with 3 components. Supposed to be there is another component, which is z. So it's going to be x squared plus y squared plus z squared. And it's going to be x prime cosine t squared minus sine t squared plus 0 squared. Then now we're going to evaluate. So here is going to be this sine squared plus cosine squared is going to be 1. And this is 64. The same thing here, because this one is cosine squared t, sine squared of t, and everything here is going to be 1. So now this is 1. 1 time plus 64 is going to be 64, square root of 1 dt. That's going to be 65, square root from 0 to pi over 9 dt. That means 65t from 0 to pi over 9. And then it's going to be 65 times pi over 9, 65 pi over 9. So we're just going to type here 65 pi over 9. Over 9. That's it for this example. For number 3, evaluate integral c to the f dr. And we have f xy, xi plus yj, and r of t equal to 3t plus 2 plus for the I plus t for the j of t between 0 and 1. Let's check how we're going to solve example 3. So here's the third one. Here is our function. Now we're going to use different rules to find the integral. You can use this rule, f of t dot product with r prime of t dt. So here's our function with x, y. I'm going to write down the component form. Here is r of t between 0 and 1. R prime is going to be 3, 1. Now f of t, because now we have f to the xy. Now f of t, a plug-in, this is the x, and this is the y. So it will be 3t plus 2, and here is t. Now the integral from 0 to 1, f of t, dot with r prime over t dt. Dot product, be careful. This one times this one plus this one times this one. So 3t plus 2 times 3 plus t times 1. Now it's going to be 9t plus 6 plus t, because we're going to distribute here. And combined like terms is going to be 10t plus 6 dt from 0 to 1. Now do the integral here is going to be 10 t squared over 2 plus 6t from 0 to 1. Plug in the 1 is going to be 5t squared. I simplified this one here. It's going to be 5t squared plus 6t. Plug in the 1, 5 times 1 squared plus 6 times 1 minus 0. So it's going to be 5 plus 6 is going to be 11. So the solution for this one is going to be 11. The last one, example 4, evaluate the integral to the line CFDR. So fxy 9xi plus 2yj, and here is r of lt. So let's check how we're going to solve this one. So f to the xy is going to be 9x and 2y in the component 4. And r of t is t and 4 minus t squared to the half. R prime, careful here, is going to be 1 half 4 minus t squared to the negative half times the derivative of inside is negative 2t. Cancel the 2 with the 2, so it's going to be negative t, 4 minus t squared to the negative 1 over 2. Now f to the t is going to be 9t. We're going to plug in here, and 2, and here's the y, because this is the x, and here's the y. So it's going to be 2y is going to be 4 minus t squared to the half. Now the integral from f to the dot product with the dr is going to be f over t times r prime over t dt. So here is f over t, and here is r prime of t dt. Let's multiply. It's a dot product, so 90 times 1, 90. This part time plus this part times this part. This is positive exponents. This is negative exponents. That means you can cancel this one with this one. So the left is going to be negative 2t. Combine these together, it's going to be 7t. And the integral from negative 1 to 1. So it's going to be t squared over 2 from negative 1 to 1. And then it's going to be 7. It's going to be half minus half, which is 0. 7 times 0. So the result is going to be 0 for this example. So plug in 0. That's it. That's it for this section. Right. This is the whole thing for section 15.2.